All right, let's talk about acid and base. This is a new topic, but you will still see molarity that comes into play when we talk about strengths of acids and bases. Okay, so let's start with definition. Right, so definition, we're going to look at acid definition and going to look at bases definition. And we are also going to look at properties of acids and bases. Acid is a compound which is capable of producing hydrogen ions, hydrogen ions, okay, which looks like H plus, okay, and H plus is actually when dissolved in water, okay. For example, you have hydrochloric acid. Hydrochloric acid obviously has hydrogen and chloride bonded by a single bond. Okay. However, here, if we look at the electronegativity of hydrogen and chlorine, chlorine has higher electronegativity than hydrogen. Now, what that does is creates a partial charges on each of the end because of unequal distribution of electrons. Okay, so here on this side you see less density of electrons, and on this side we see higher density of electrons. Okay, so when that happens and you put this substance in water, which water which is polar, these chemicals like hydrochloric acid tend to separate into hydrogen ions and chloride ions. Technically, you are mixing water with hydrochloric acid, so you expect to get H3O plus and chloride minus. Okay, so basically what is happening is that this HCO breaks down into H plus and Cl minus, but then this hydrogen goes and pairs up with this oxygen to give you this ion right here, which is called hydronium ion. Okay, nice. So that's what an acid is. Compound that is capable of producing hydrogen ions in water. Okay, so let's look at its properties. Okay, so first physical properties. Okay, acids. Acids tend to taste sour. Okay, your Sour Patch thingies, they're acidic. Okay, lemon is acidic. Apple is acidic. Okay, similarly, oranges are acidic. Okay, uh, smell. It feels like it's burning your nose. Okay, when you smell, it burns your nose. Sorry, burns nose. Burns smell. Burns nose. Okay, for example, when you burp and if you had too much acidity, and when the burp comes out of your nose, sometimes the gases come out of your nose tend to burn a little bit. That's because we have hydrochloric acid in our tummy, and when you have too much um, food, acidic food, your body, when you burp, you tend to get that smell. Okay, if you touch acid, it will feel sticky. Okay, so those are your three physical properties. Your chemical property of acid is that if you mix or put metal, for example, zinc in hydrochloric acid, you tend to produce bubbles, and those bubbles are of hydrogen gas. I have actually done this reaction for you guys last semester, where I placed silvery white, zinc pellets in hydrochloric acid and it gave bubbles. Okay, right? So that's all about acid. Okay, let's talk about base. Okay, let's talk about base. Okay, base is opposite of acid. Okay, so if acid is produced able to produce H plus, bases are able to accept hydrogen ions. Okay, hydrogen ions, or base is also able to produce hydroxide ion. Okay, for example, let's take an example of ammonia. Okay, ammonia, NH3, that's the regular house cleaning supply we use, right? Ammonia is a base, and if you put hydrogen ion in it, it gives you this ion right here. Anybody know the name? It's the only polyatomic ion on your list, on your star reference sheet. Okay, this is ammonium ion. Okay, similarly, for example, if you have NaOH, right? It's in solid form. If you place that in water, NaOH tends to dissociate into sodium ions and hydroxide ions. Again, this one is also in your star reference sheet. Okay, so here, okay, either they're going to accept hydrogen ions or they're going to produce hydroxide ions. Basically, they are opposite of each other. Acids and bases are opposite of each other. Okay, all right, let's look at physical properties. Okay, physical properties. So, well, let me write that all the way down here so that it's on the same line. So that it's on the same line. Okay, uh, properties. So let's look at this one. Physical property. Physical property of bases. Okay, if uh, acids taste sour, bases taste bitter. Okay, you guys can think about what things, taste bitter. Anybody had bitter melon ever? They taste really bitter. Okay, smell, usually it does not smell. Okay, so doesn't have smell. Okay, as opposed to acids being sticky, these guys, base, feel slippery. Okay, and lastly, chemical property. One of the most important chemical property of bases is it reacts, remember the code word, with oil or fat. Okay, for example, if your kitchen sink is clogged, okay, because you accidentally dumped ton of oil in there, right? It's blocked. Now, if you use Drano, which is basically a mix of really concentrated um, strong bases, sodium hydroxide and potassium hydroxide, it clears the clog away because it reacts with oils and fats. Okay, all right. Moving on, you guys do need to know about pHs. Okay, that's how we measure the intensity of acid and bases. Okay, so intensity of acid. Okay, measured by pH, which is also called power of hydrogen. Okay, we have a lovely chart. Okay, it's called the pH scale. It runs from 0, sorry, that line's not that great, to 14. Okay, 0 to 14. So right around the middle is 7. So right here is your neutral point, okay, or neutral pH. Okay, the one thing that is very essential for us human beings is water, and water has a pH of 7. Now, if your pH decreases and goes below 7 and goes towards 0, the acidity increases. Okay, and if the number goes above and goes towards 14, then your strength of base increases. Okay, for example, anything at pH of 0 would be lime or lemon. Okay, or acidity, lemon or lime. You can also have Coca-Cola. Okay, then towards your bases, the most basic substance would be your soap, shampoos, right? Also, when you get heartburn, you tend to take Tums, and that is also is more basic. Okay, meaning when you take Tums, the chemical in the Tums reacts with your um, tummy acid, and that's how it relieves you. Okay, all right, and